Hello everyone. This is Shubham Board from Phenolox Academy of Management and Technology Ratnagiri. We are doing our project on process for breaking down lignocellulosic biomass to glucose for bioethanol production, and we are using rice straw as our lignocellulosic biomass. So my project mates are Arjun Busnar and Rohit Gaikwad, and we are doing this project under the guidance of our Professor Anna Sahib Bansode sir at Chemical Engineering Department, Phenolics Academy. So in this project, in this presentation, we are going to talk about some points. That is introduction. We are going to give a short introduction about our project and why our using rice straw as our lignocellulosic biomass. Then we are going to tell you about some literature survey we have done for this project and the processes and methods, and we will conclude our project with the our future work. So as we all know that as we have entered in third millennium, we have more global issues to tackle and to find solutions to them. So our project is a good example of using renewable sources to tackle the global issues right now. So why we are using biofuels in a why what are the biofuels? So biofuels are the liquid or gaseous fuels made from the plant matter and residues such as agricultural crops, municipal waste, and agricultural and forestry byproducts such as the fallen leaves of the trees, etc. So why we are using biofuels right now? Why we are focused on the biofuels? The focus toward renewable sources is due to the depletion of crude oil reserves. As we all know that the crude oil reserves in the world are going to deplete sooner or later. So we have to find the solutions for this current situation. So the advantages of biofuels are they are renewable resources that can be sustainably developed in the future, and which have effectively positive environmental impacts and are significant economic potential. So why we are using biofuels? Biofuels are reducing the rice crop residue, and increasing proportion of rice to undergoes field burning. So India is second largest country which produce rice. So most of our rice straws are get wasted, and we are burning the rice straws. The farmers are burning the rice straws in the crop fields. So we are contributing to the global warming or climate change. So to tackle them, the rice straw has a potential to convert it into an energy. So that's why waste of and which is waste of energy. By using the rice straw, we are stopping the waste of energy. Given the high fuel prices and the great demand for reducing greenhouse gases such as CO2, NO2, or etc. So as well as we are stopping the air pollution also. We are helping to stop the air pollution also. So the next slides will be presented by my project mate Rohit Gaikwad. Rohit, please continue.
Yes, Shubham, thank you.
Rohit,
So our sources of
yes sir.
yes, Shubham.
Yes, continue.
So our sources of lignocellulose biomass are three main sources we have. That is forestry, agriculture, and waste. Right now we have three sources, but our uh, uh, raw material is agricultural byproduct. So rice straw, mainly in Konkan region, rice straw is uh, usually produced in our area. So we as a raw material. So agriculture product sources, agriculture source is our raw material. So we go through agriculture byproduct and byproduct of agro industries. Then we go to pre-treatment. After pre-treatment, go for physical pre-treatment, thermal pre-treatment, chemical pre-treatment, and biological pre-treatment. In physical pre-treatment, we first do irradiation, and then we do pre-treatment. We first do steam explosion and hydro. thermal. In chemical pretreatment, we first do acid treatment and alkali pretreatment. And last is biological pretreatment. In biological pretreatment, enzymatic and microbial pretreatment is done. Next, we have done literature survey on this. So these steps are involved in bioethanol production. Pretreatment, there is enzymatic production. There are such process like PPP, SSCF, SSF, SHF. So the CP, uh, enzymatic production plus hydrolysis and exhaust and penton fermentation. Those, fermentation. And SSCF is enzymatic hydrolysis, exhaust plus pentose fermentation. In SSF, enzymatic hydrolysis and exhaust fermentation. And in SHF, enzymatic hydrolysis is done. After we go further in SSF, uh, uh, pentose fermentation, and after SHF, we do exhaust and pentose fermentation. After that, we do product recovery, and final product is our ethanol. So another step involves our pretreatment is physical, is that mining or chemical. Example, alkali pretreatment. Enzymatic hydrolysis equals cleaving polymers of cellulose and cellulose using cellulosic enzyme. And fermentation involves ethanol is directly produced from metabolic activity of fermentation agent. So next slide will explain by Arjun. Arjun, please.
Thank you, Rohit, and thank you, Arjun. So we have explained you the short scenario about our project, and the processes involved for the bioethanol production from lignocellulosic biomass, and why we are using rice straw as our biomass. So up till we have studied these processes, this much of processes, and this review briefly describes the aspects related to bioethanol production and focuses on both theoretical and practical approaches for process involve improvements and several green emerging distillation techniques such as ohmic assisted hydrodistillation or membrane assisted distillation and heat integrated techniques are shown to be energy saving alternatives to conventional distillation processes for bioethanol production from lignocellulosic biomasses. In future, we will attempt to develop a new process for bioethanol production. And this is the short picture of how the bioethanol production will be done from a from corn. So thank you everyone. Thanks.